Hello, this lesson is about capacitors. Let's learn what they are and their applications in a circuit. So, what are capacitors? Well, capacitors in a circuit are devices that are used to store electric charge. Okay, it has many applications in circuits, and it's present in almost all electric devices we have nowadays, right? And they consist of a pair of conductors charged with the same charge module but of opposite signs, and it's separated by the dielectric. Remember that a dielectric is a material that's an insulator. It acts as an insulator, but when we reach a certain amount of charge, electric charge, it acts as a conductor. Okay, so we have a lot of different types of capacitors. Here are some examples for you to see. It's very common to see them in small circuits in almost all electric devices we have nowadays. And in a circuit, it's represented with these symbols here. Okay, so it's a pair of conductors with the same charge but with opposite signs. Okay, and it's separated by a dielectric. Alright, so a very important thing to know when dealing with capacitors is the capacitance. The capacitance is the amount of charge stored per volt. So that's the main functionality of the capacitor, right? To store electric charge. So we can calculate the capacitance of a capacitor by taking the electric charge and dividing by the electric tension between the two surfaces of the capacitor, okay? And the unit we give it's a Faraday. 1 Faraday is 1 coulomb divided by 1 volt. For a parallel plane capacitor, that's a very simple capacitor we have two conductors that are plane and they are parallel, okay? For this situation here, we can calculate the capacitance using this formula. So here we have the dielectric constant of the dielectric material between the capacitor, the two conductors of the capacitor. We have the permittivity of the free space, all right? And the area of one plate of the capacitor in square meters and the distance between the plates of the capacitor. As almost all components in a circuit, we can put them in series or in parallel. For capacitors, in series like this, we can calculate the capacitance of each capacitor and find also an equivalent capacitance, right? So for this case here, for example, we know that the tension, the equivalent electric tension for a circuit like this, we can just add up the tensions, alright? For the capacitance, then, we know that the tension, the electric tension, is actually the charge divided by the capacitance. So we can do it for each one of the capacitors, and well, the charge remains the same, so we can calculate the equivalent capacitance with this formula here. Similarly, in the parallel circuit like this, if we have parallel capacitors, we can apply the same thing. We know that the tension actually is the opposite, right? So the equivalent capacitance, we can just add the capacitances of each capacitor. So remember, it's always kind of the opposite of the tension. So to calculate the tension in series is the same as to calculate the capacitance in a parallel circuit, alright? And the same for series and parallel, but now with the tension here and the capacitance here, okay? Okay, now that you know how to calculate the capacitance of a capacitor and its relation with the electric charge and tension, think about this problem here. So, what is the capacitance of a nylon parallel plate capacitor with metal plates, each of area of 1 meter squared, separated by 1 millimeter? So, nylon is the dielectric of this capacitor here, okay? And it's a parallel plate capacitor. Also, what is the charge that is stored in this capacitor for this electric tension here, for this voltage? Okay, so I'm giving you the dielectric constant of nylon, that's 3.4. We can find it in several tables and books, okay, for different materials, and also the permittivity of free space. So your calculations and comment your answers in the comment sections.
What did you think about this video? We appreciate your feedback, so tell us in the comments section.